What is rotational motion? Rotational motion describes an object that rotates about a fixed point. Whether it's a door, a wheel, or a wrench, any object can go through rotational motion if they have an axis point. The equation for moment of inertia is the sum of all mass times radius squared. Similar to torque, the farther you get away from the axis point, the greater the moment of inertia. Moment of inertia is the resistance that an object experiences against rotational motion. I have a stick here, and on either side, it's pretty fairly weighted. When I turn the stick, it's pretty slow. This is because the weight of the object is put far away from the axis point. Now, if I were to shrink it, I can now spin it a lot faster. Because the mass of this object is now closer to the axis point, moment of inertia is decreased. I have a chair here. It spins. I also have two 2-pound weights. When I spin with the weights close to my center of mass, it's much easier to move. As these weights move away from the center of my body, it becomes increasingly difficult to spin, and I have to apply more force in order to spin at the same speed as I did when the weights were close to my center of mass. The same force that opens this nail polish also allows this pop socket to spin. This is torque. When a car moves forward, its wheels experience both translational motion and tangential motion. The center of the car's wheel only experiences translational motion. However, the top of the wheel experiences both translational motion and tangential motion. The bottom of the wheel experiences tangential velocity opposite direction to the translational velocity. This is why the car moves. If at the bottom point of this car's wheel, it were to experience tangential and translational velocity in the same direction, the car would be unable to move. An example would be a car skidding on ice. The bottom point of the wheel is moving. However, the wheel isn't experiencing actual rotational motion. When tangential velocity and translational velocity add together, it creates twice the speed as the center, while at the bottom they both cancel out, which allows the car to move forward. When opening a door, the more force you apply onto the door, the faster the door will open, which means there will be more torque. However, where you apply that force affects the amount of torque. Torque is found through the equation radius times force times sine of theta. This means that when opening a door, the larger the radius is between your hand and the axis point, the more torque that is generated. This is why door handles are placed so far away from hinges. The farther away from the hinges you push a door, the faster you are able to open it with less force. However, as you get closer to the hinges, the force you apply has to be greater in order to make up for the less radius. Translational motion and rotational motion are extremely similar. Just like all forces, torque also has the ability to do work. People experience rotational motion every day, whether it's a car, a bike, or maybe just opening a water bottle cap.